Okay, so as I was saying, so far we learned how to build applications, right, on the front end. And these applications have pretty much everything you need except for connecting to a backend, right? We can build an application that has pages, that have components, that has interactivity, so we can enter data, we can capture the data, we can react to events, we can click on elements on the page, and we can pretty much build anything visually on the UI, right? Now, that information that we capture somehow has to go to the backend. And in the same way, information that's stored in the backend has to come to the front end, right? Because remember, the backend is the resource that has all the information, has all the logic, all the information. In reality, the front end job is just to query data, show it to the user, and capture data and send it to the backend, right? We don't put logic, like business logic, in the front end. That's not a thing. We do that on the back end, right? Because remember, whatever you put on the front end and whatever you are accepting from the front end, you have to take it with a grain of salt, because essentially it's in the another person's computer, and they can pretty much manipulate whatever they have there and send us wrong information. So you should not put logic on the front end. All the logic should be in the back end, and all the resources should be on the back end, right? And today we're going to learn how to make that happen. Now, the way it usually works is you have your web page, and you have a backend API over here. And then you connect from the front end, you make a request, and the backend sends a response, right? So in this model, what we have is that, first of all, the application is always the one that is initiating the communication, right? The application is making a request, and then the server is sending the response. For every request, you get a response, okay? Even if there are ways for the backend to notify that something happens to the front end, right? That's not the common way we communicate between the front end and the backend. It's basically the app sends a request, gets a response. Sends a request, gets a response. Okay? Now, this request and response responses, they are not instantaneous, right? Sometimes you send a request, and a lot of things can happen. And essentially, the first thing that happens is that you still have the speed of light, right? This is the maximum, I think it's theoretical limit that you can transmit data, right? So you have that. That means that even if you are here and you have some API or data center in California, for example, it will be faster for someone in California accessing that data than someone in Miami, right? It's because it's closer to the data. That's a reality. So it takes time for the request to get to the server, and then it takes time for the server to respond, right? And then in the server itself, you're dealing with basically a lot of operations going on at the same time. So depending on how much capacity that backend has, and how much let's say CPU and memory and all the other stuff that API has or that server has, then you will have your request can take milliseconds if it's something really fast, or it can take even seconds, right? Even a minute, I'm not sure. I mean, sometimes it takes more than a minute, especially if you're making a big query that has to compile a lot of data and then return it, right? So what I'm saying is that this request and this response take time. So far, every time we call a function, every time we call a function in JavaScript, this function is really fast, right? It's milliseconds. And what happens is that every instruction gets executed, and the next instruction has to wait for the previous one to finish, right? So that's the way most programming languages work. So you are basically executing all the instructions in this order, right? From top to bottom. And every instruction has to be executed until the next, and then the next one, and then the next one, etc., etc. Now, when you're making a request, let's assume I have, for a second, that I have a function called query data. And I'm querying for some data, I don't know. Right? And making this query. Now, the nature of this request is that they will take time, right? So something like this is actually a problem, because if we have something like this, then that means that our application will get stuck in that point, because it's sending the request and then it's waiting for the response to come back, right? We technically don't want that. We will see later that that's actually kind of the way we should do it, but what happens is that we created, in JavaScript, there was created something called, I don't know why I cannot write, something called promises. Okay? Now, this was the solution that JavaScript implemented to solve a synchronous event, right? So a promise is a special object in JavaScript. So remember that we added, remember that we have strings, booleans, numbers, we had dates, we had objects, we had arrays, we had GSX, right? Like a special type of data that we can store, and now we have promises. Now a promise is a special object that can be in 3 different states. Only in this. So the first state is unresolved. Okay, so the first state is unresolved, and the 2 other states are resolved. Unresolved, sometimes you will see it as pending. So pending, and the other state is resolved and reject. Okay? Now, what this means is that it can only go from this to this, and okay, so it's a special object, right? So it's the promise, basically it's the promise of a future value or a future response, right? So basically when you make a request, right, the function that returns that request, that made that request, is returning immediately. But it's returning not the result of the request. It's returning a promise of whenever this response comes, that promise will be resolved or rejected, depending if it was a successful or a failed execution, right? So there is a special function in JavaScript called fetch. And this is the function that we are going to use. I will explain how this function works in a minute, but this is the function that we're going to use to make API requests, right? The name is fetch, and when we do this, let's say we do rest equals fetch, and we're making a fetch, we're querying a backend. This variable is not the response of the request, right? We're making a request, and fetch is just saying, okay, this is a promise of the result, of the response, right? It's not the response yet. Initially, that promise is in the pending state. That means that, yeah, the query was made, and we're waiting for the result, right? Now, as soon as the result came, right, the response, the server response, we get one of these 2 states, right, the promise goes to one of these two states. If it was a successful request, it will be resolved, right? And resolve means that you can get the data out of that, right? You can get the response. If it's rejected, you can get the error code, right? Now, fetch is kind of like, fetch doesn't play nice with this type of logic because sometimes, and we will see how APIs work, but technically fetch should reject when the server responds an error, and it's actually saying resolve, but then you have to check the data and see if the data is from a valid or a failed response, right? So what I'm saying is, we have this object called promise that we have to start using. Now, what happens with fetch? And fetch is one of the functions in JavaScript that returns a promise. There is a lot of functions in JavaScript that return promises. Fetch is one of those. Or you can just have a function and say new promise, and you can just create your own promise and just, for example, if I want a function that waits 3 seconds and then do something, right? That could be a promise because you can put a delay and then say, okay, delay 3 seconds and then resolve this promise. And then you can tie code up to when that promise gets resolved and then execute that code, right? So that code gets executed once the promise is resolved. And let me explain how to do that. So for that, if you're using promises, let's say I'm making a fetch request to https myapp.com/API/todos. We will see how to use it. We will see what the parameters of fetch is in a second. Now, I know REST is not the response. It's just a promise, right? So a promise, I can do two things with a promise. I can call a function called then, has its own parameters, or I can call a function catch with its own parameters. Now, then is the function, I can pass here a function, right? Similar to cache. Like this. Sorry. So when I have a promise, I can call the then function of the promise and pass a function, right? That means that when this promise gets resolved, whatever data that promise has, it will be executed in this function. So this function will get executed, passing the data. If this promise fails, then this function gets executed, and the error, the failure error, is going to be passed. So I can react to a successful request or a failed request. Yes?
What will happen if the promise is resolved, but you haven't sent the function yet?
Nothing happens. If you don't call, like, that's the other thing. Let's say you call this function and you don't do anything, you don't call then or cache, nothing happens. The promise the function is still executed and the query still gets called. But the thing is that you are not using the response, right? That's all. Or you are not using, if you are optimistic, and you will see that a lot.
Once you send, it will pass normally.
Yeah. The thing is that this is going to be executed in order, right? So if you put let me explain. If you put a console log here, right? Even if this request takes 3 minutes, right? When I execute this code, I will see here immediately, because it's executing all these instructions, one after the other, right? You will see here. And then 3 minutes later, you will see whatever this then function has. You will say, okay, now the response came up, and I'm executing the code that I set for the response to be successful. If after 3 minutes fails, then the cache will be called, right? And that's a way in JavaScript. By the way, what I'm teaching you now is foundational. That doesn't mean that we use this today, right? And you will see in a lot of documentation that people try to avoid using then and catch, right? Because it's really hard to understand. The other thing is that what if you have a function, and this is very common with fetch, that, okay, you have the response. Actually, this is the response, right? But from the response, you need to get the data. So you have to do something like this. Return response.json. And response.json is a function that also returns a promise. So now you have to put another promise here. So it becomes a nightmare, right? Because you have to cascade then after then after then, because you go from one promise to the other, to the other, to the other, and then you put a cache at the end. So you will see code, you will see basically a lot of code doing something like this. Doing a fetch, and then saying, okay, when the response comes, do this. And then I will have the data. And that's probably what you have in the documentation or the lesson, right? And then if there is an error, I will do a catch, and I will try to catch the error.
And based on the error code, you can then have it execute other code.
Yes, but the problem with fetch is that fetch doesn't fail, doesn't reject the promise unless it's a very, I would say, catastrophic event. It's like loss of connectivity, or like when the request could not be completed. But sometimes the request can be completed, and we will talk about that now, but the error code is failure, right? If there was a successful request, but you get that here. So now here you have to say, oh, wait, no, here, actually here. You have to say, oh, if the response status is 200, then I can do this, right? Else, I know it's an error. So it's kind of problematic. That's what I'm saying. Now, this is the way we treated asynchronous code or asynchronous calls or asynchronous fetch probably 5 years ago, 6 years ago, when promises were introduced in JavaScript. Probably a little bit longer, actually. Probably 10 years ago. But after some time, we introduced something like this, async await. And you probably seen me before using async and await in some code that I wrote, right? Async await are basically a couple of modifiers for two things. First of all, you have to think in terms of functions. Functions can be of two types: synchronous functions. Hopefully I wrote it well. The other one is asynchronous functions. Synchronous, I think it's correct, yeah. Right? Synchronous and asynchronous. So all functions in JavaScript are one of these two types. Now, how do we know? By default, all the functions that we've seen so far are synchronous, right? Because they are just function, I don't know, something, some. Right? And we do something and we return. So that's a synchronous function. Now, what is a synchronous function? It's a function that has the word async in front. That's all. And these functions, the point of this function is that to denote that this function will return a promise. Right? So when I see a function that is asynchronous, using the async modifier, then I know that this function might return a promise, and actually will return a promise, right? Because it's an asynchronous function. When you call it, that function most of the time returns a promise. Okay? Now, we can do, let me put you two examples of the same function in a synchronous form and an asynchronous form, right? So for example, sum, this is, doesn't need to be asynchronous, right? Because summing is super fast, we don't need to do asynchronous. But just, let's make it an asynchronous version of this. So A plus B, and this is the synchronous version of the function, right? The one that we use all the time. Now, if I want to make an asynchronous version of this function, I mark it as async, right? A and B, and I would say return promise resolve A plus B. So now this is an asynchronous function. So this function is asynchronous and is returning a promise of the sum, right? So it's returning the sum, but as a promise. Of course, it will be a promise that will be resolved really fast because it's just returning a resolved promise. Now, the way we call this is, if we want to use the synchronous version, we do something like this. We know this already, right? It's the way we call functions. Now, if we want to use an asynchronous function, we have to do sum, let's call this A, sum A, and then we have to do then, and we can do whatever we want with C. Right? Because it's an asynchronous, what it's returning is a promise. If I try to console log, and actually, let's see this in, so if I do console log C, I will see 3, right? It's just a synchronous function. I'm just calling that. But if I call the asynchronous version of this function, I will get a promise, right? And that promise is in one of 3 states: unresolved, resolved, or rejected. If it's resolved, I can ask for the data. If it's not resolved and it's rejected, I can ask for the error. And if it's pending, I can do anything. I can do nothing with it. And by the way, one of the issues with promises is that you cannot cancel them initially. Now you can cancel them, but that was a really big problem, because if you're making a request and then you say, okay, this request doesn't make sense anymore, you cannot cancel, right? That was a problem because I mean that's exactly. Now there's a way to cancel promises, but that was not the initial design, right? So, and how do I get the data out of a promise, right? C dot then. Actually, I don't have C. What I have is whatever this is returning, I do dot then, and then I know that the data will be passed. So console log C. Okay? And you will see 3. Because what is returning is a promise. It's something that is encapsulating, right, the value or the future value. In this case, it's instantaneous because it's just adding that and returning. Now, because it's async, and that's the beauty of async, we don't have to do this dot then anymore, right? When we have asynchronous functions, we can use the await. Remember, async is the word that we use to denote that a function is asynchronous. You see, async function. Okay? Now, we use await as a modifier to call an asynchronous function. Right? So when we have something like this, we don't need to do dot then, dot cache. We don't need to do any of that. And now functions, asynchronous functions, behave like synchronous functions. So that means that when I say await, I can put the console log just behind, just after. That means that it will stay there until the promise gets resolved, and then it will do the next line, right? And this is a lot easier to reason about, because you don't have to think, if this thing comes first and then this comes after. No, you don't care about that. right? You know that it will await for the promise to be resolved and then continue the execution, right? Now, the only problem with await is that you can only use await inside an asynchronous function, right? So it's like a catch-22 type of thing, right? Like right here, if I have this promise and I try to do this, const c equals await sum a, this will fail because I cannot put await in the free. I have to put await inside an asynchronous function, right? Now, the trick is to, this is the trick that everybody does, is just create an ad hoc asynchronous function. You can call it fn if you want, like really. Right? So now I can use it because it's inside an asynchronous function, and then I just call it fn. And that works. Okay? So that's the only rule with async await. So all your functions, all the functions that are asynchronous, you put async. And if you want to await for the execution of an asynchronous function, you put await in front of it, and then you will get the value. But the only restriction is that it only works inside a synchronous function. Okay? Make sense? Now, with React, there is some ways that we can use asynchronous functions in React, right? Of course, React functions cannot be asynchronous. They are just synchronous. Okay, so the other thing with async await, so we need to talk about fetch. Now, fetch is a function in JavaScript. That means that it's already included in the browser and it's included in the language. And fetch is a function that will allow me to make HTTP requests. Okay? Now, an HTTP request, remember, HTTP is the protocol that the browser uses. If you see the URL from every browser, you will see right there, HTTPS. That's the secure version of the protocol. So that means that every time you go to a web page, you are making HTTP requests, right? Every time you get the JavaScript for the page, every time you get the HTML, the CSS for the page, that's a request that the browser is making to an API, to a server, right? And it's getting all the pages and all the JavaScript and all the resources that it needs, all the images, etc. Okay? Now, we can make our own HTTP requests from JavaScript to get data. That's what we do with HTTP. We get data. Because for the HTML, CSS, and images and all the other things, we have the browser with React doing that part. But from our applications, when we want to get data from the query data from the backend, we need to make a HTTP request. Okay? Now, in terms of HTTP requests, the HTTP requests have several properties that we need to understand. The first one is the method, right? I would say there are 4 or 5 main methods, being get, post, put, and delete. Sometimes you will see patch, but it's kind of like, it depends on the semantic. I think most people use patch instead of put. No, put is also a one. Optionals, you will see options is another method. Now, the method is basically what type of request are you making, right? It has a semantic of what type of request are you making. Get request is always query data, right? When you make a get request, basically you're querying data. By the way, every time you browse the web, you're basically making a lot of get requests, right? All the requests that you make, all the web pages that you download, the JavaScript, images, etc., they're all done using get requests, okay? And actually, you can see it. If you open a browser like right here, for example. If I open the browser and I browse any page, you see all these requests, and open any of these requests, you will see that the method is a get, right? So everything that you see here is a get request. All the images, all the JavaScript. By the way, a lot of JavaScript. Okay, this is an image, I guess. So everything is a get request when you are browsing the web. Okay. Now the second important part of a request is of course, the URL. Right? You're making a request to some URL, and of course, this URL has a domain, and it has a path name, and it has query parameters, and it has all the elements of the URL. Correct? So you need a URL, you need the method. By the way, I said get request was for querying. Post request is usually used when you are creating new items. You send a post request with all the data that you require. Patch and put. Well, patch is basically modifying data. In this case, you don't have to send. The semantic is that you don't have to send the whole object. You only need to send the modified data. That's what it's called, a patch. And delete, of course, is just to delete data from there. Now, that's the semantics. That doesn't mean that the backend is actually deleting the data, right? It's just saying, okay, I want to delete this data, but then the backend say, okay, I will delete it, and I'll just put a mark here saying that I deleted, and they don't delete the data, right? That's actually a good practice. Yeah, don't never delete data, because you know, I mean, you probably know. You delete the data, that's no way to recover it. You never delete data. You just mark it as deleted. Unless a lawyer or a judge says to have to delete it. But that's another. Okay, the other thing that you have are the headers. Now, headers is metadata about the request. So metadata about the request. What this means is that requests are kind of like anonymous in the sense that the backend doesn't know who's making the request, right? It's said that when you send this metadata, you can say, okay, I am this person, and you can somehow guarantee that that person is the one that is actually saying that it is, right? So here you will have headers for example, the content type, right? Because you're sending data to the backend, but the backend needs to understand how are you sending this data. So you will see here like application JSON, right? This is a typical header, content type, application JSON. That means that I'm sending JSON, right? JSON is, remember, is the JavaScript object notation. It's like an object in JavaScript. That's the kind of like the standard format in which most web applications and backends send data, right? But we need to tell the server, I'm sending you JSON, or I'm sending you text plain, or whatever, or text XML. Well, it's not technical text XML, but you get the idea, right? So it's what type of data I'm sending. Another typical request is the authorization. Sometimes when you make a request, you want to send a token. That token will identify you. It's like sending a password, right? Kind of like a way to identify who's making the request. And based on that authorization, the server will allow you to access some data or not. It will filter the data you have access to. So what I'm saying is that the headers contain, sometimes you will see cookies here, right, also. So headers are basically information about the request, okay? And last but not least, we have the body, right? The content, the payload. So GET requests don't have a body because they don't need to send a body. But if you have a POST request, a patch, probably not delete, you need to send data, right? Because basically you are taking data and sending it to the server. You need to send that data as well. Now, in terms of the response, the first thing that you get is the status code. Okay? Now, status code are a three-digit number. Starts with starts with 1, 2. We have the 3s, the 4s, and the 5s. There is no 600 code. There is no 022. It's always 3 digits, and it starts with 1, with 2, 3, or 4, or 5. And each segment of this number has specific meaning. So, honestly, I don't remember what ones are. You can Google it and let me know. 200s are okay or successful, as in general. For example, you will see here the typical 200, right? 200 means success, and here's the data, right? When you make a request, the server responds with data. It will send you a 200 request, a 200 response, and it will send you data back. For example, 201 means is the typical response when you make an operation that data is created. It will send a 201, meaning, okay, everything was successful, and I stored the data. That's a 201. I think 202 is like, everything was successful, but I'm not sending you any data, right? So whatever operation you call, that's it. I made the operation, but I don't need to send any data back. That's a 204. Then we have the 300s. This is usually used for redirects. Very uncommon in APIs. You don't see that commonly on APIs. We have 400s. These are client errors. Client errors typically mean, for example, you've seen this before, 404, right? Not found. So you ask for a resource, the resource was not found. The backend sends an error 404. But notice that this 404 means the client made a mistake, right? This is a client error because you try to access a resource that doesn't exist. So that's not found. You also have 401, 403. This is authorization, forbidden. So 401 is you are not authenticated. Get out of here. 403 means, okay, you are authenticated, but you don't have access to that resource. 401, 402, I don't remember. I think that pretty much, 400, this is pretty common as well, is that when you are sending data to the backend, but you are not using the format that the backend is expecting, then the backend can send you a 400, meaning the method or the data is not correct. So you know that something in the client is incorrect. And then the 500s, and this is the worst type of errors you can see, because that means that someone in the backend is doing something wrong, right? Especially 500. This is coding error, it's like fatal error. It's unrecordable, basically, because when you make a request and the server crashes, what you get back is a 500 error, right? But server crashing means someone made a mistake in the server, in the backend, right? So there is no way to recover from that. Someone has to go in and change the code. There is another set of error here, 502, 519, I guess. I don't remember. But yeah, it's a bunch of them. So we need to check the status. That's what I'm saying. So the status is the first thing. We also get headers. Headers also include content type. You can include data. You can include a bunch of stuff. You can include cookies as well. So it's basically information or metadata about the response. And you can also have a body. And that's the response data. Okay? Yes?
For authorization, you're passing something in like a password or something, right?
Not the password. What you usually pass is like a token.
Like a token?
Mm-hmm.
If that's like where would you put it? Like, if you have it in your JavaScript, can somebody like go in and see it? It's like inspect elements.
Technically, yes.
Yeah.
Technically, yes. If you know where to look, but the thing is that you are protected because nobody's accessing your account, right?
Yeah.
So it's your browser, it's your machine. But that's why if you have Facebook, try to open the terminal with Facebook in the Facebook page, in the Facebook, maybe Instagram has the same. Try to open the terminal and check what it says there. It's like it would say, do never put anything here. If someone asks you to put something here, don't do it because they're trying to steal your information, right? There was like a thing before that people say, oh, if you want to access some other people's pictures or you want to see what other people's writing about you, copy this JavaScript code and paste it in your terminal. And that thing, they didn't know JavaScript, right? So they was just pasting that, and that thing was just hacking them, right? Just taking that token, sending it some server out where, and then they would say, oh, someone put the code, and now we have the token. If you have the token, there's nothing you can do, right? Yeah, definitely. That's why extensions are so dangerous. Like Chrome extensions,
They can grab them.
they can access the browser, the page.
Yeah.
Anything that the page has access, they have access, right? So if it's not an extension that you trust, don't install it because they can just cut whatever page you open. The extension is running in that page, right?
Yeah.
So yeah, be careful. Cool. Questions about request and response. Let's see how fetch allows us to create this request and this response, right? So fetch is a function, and it has two ways to use it, right? The first one is if you put a URL, just a URL. This is a GET request, no question asked, right? This is the simplest way to make a request. Just fetch URL, that's it. It will make a request to that URL. By the way, I know we have a to-do API, and this to-do API has a way to get the users let me see if I can try this. Oh. Okay, I will use a terminal here. So there is a command in the terminal that you can use to make requests. It's curl. It's a Unix type of command, so it's only on Unix, Linux, probably Windows if you install the right extension. But curl is essentially it's a transfer URL, but I don't know. It's a tool that someone wrote like 50 years ago and it still works, right? It's pretty useful. So with curl, you can put a URL, and it will query that URL using get, right? And you see that this is the response. Now, if you want to see all the data, it's a command. Oh, interesting. Options is not available.
Error code 405.
Huh?
405 is the error code.
Yeah, that's the error, but I want to see the status. What I want to see is the data. It's the. Oh, okay. More detail here. So you see, it's trying to make this request. Get to /to-do users Ernesto. So that's the path name, right? And the host is playgroundforgigs.com. That was the URL that I tried to access. Playgroundforgigs.com /pathname, blah, blah, blah. And you see the headers are user agent, accept, those are the headers, right? This is the request, this is the method, this is the path name, and these are the headers. And then this is the response. 404 not found, right? That's what I get. And then these are the headers. report to, reporting endpoints, nail, connection, date, server, content length, content type. So it returned it, and in the format was application JSON. That means that the response came in JSON format, you see here, and it had 47 bytes, right? So that's a request and a response. I don't have an account. Oh, I can create one. Okay, let me create my account. Oh, try it out. Okay, so this is the request. This is the request to. This is a post request to the same URL, and the headers are accept application JSON, and in the data I'm not sending anything, right? So I'm making a request to this URL, a post request with that header and that data, right? So what I'm saying is that you see that the data for sending a request is the same. Method, URL, data, and headers. Okay? Now, let's check how can we do that using fetch. So again, if you're just making a request to a URL, just do fetch and the URL, right? Fetch and the URL, and this will make a request. What is this function returning? A response promise. Remember, this function returns a promise. Now, if I want the response, I can do await fetch, right? So whatever this function is, whatever this request is returning, I will get it as the value. I don't have to await. Now, after we get the response, we need to check the status, because remember, if it's 200, it's okay. If it's 400 or something, it's not. So we have to say if response status equals 200, right? That means that we can query for the data. If not, then we have an error. And we decide to do with that error. Now, what happens if we have a correct response? We need to get the data from the response. Now, to get the data from the response, we need to do response.json. Now, if you check the documentation for this function, it will tell you, oh, this is an asynchronous function. So it's returning a promise. That means that I have to await for this as well. And once I have the data, I can do something with the data. Got it? So this is a GET request. This is kind of like the way we handle a GET request. Questions for GET requests? We will use this API in a minute. By the way, let's try to use it in JavaScript. I will come here and I will make this request, and I will console log the response. Oh, by the way, I have to put this in a function. So async function. Okay, this and this. And then call it. Okay, so let's see what we get. Oh, of course, response has a bunch of stuff. Status 200, right? Now, because we have a 200 message. Wait, 200. Oh, because I created my yeah. So if I have if the response.status is 200, then I can query for the data. So data await response.json. Now I will open the network so you can see the request being made, right, to that URL. You see it there. This is the request. Let me see if I can open. How do I see the? Well, it's a GET request to that URL. And yeah, I want to see the headers and all the information. Shit. Okay. Well, so this is what I get as a response. I get an object that has name, my name, and then to-dos is an empty array, right? So the data that I'm receiving is empty, has nothing in it. My to-do list is empty, basically, right? And you see that we're making the request, we're checking the response, and after we check the response, we have to get the data out of the response, okay? And we use a wait here for waiting for the fetch request, and we're doing a wait here for waiting for the JSON response. The reason behind that JSON await is because if you have a lot of data, parsing that data into JSON can take time, so that's why it's an asynchronous call, right? Cool. Now, if we want to send data using fetch, now fetch has has a different parameter. It's an object, and inside that object you can specify method. You can specify URL. And you can specify headers. Header is an object, right? I would leave it as an object first. And you can specify the body. Right? So method, URL, headers, and the body. Okay? That's how we make a fetch request. Now, with specifying all the data, right? By the way, you can say here get if you want. You can make a get request as well. But you can make a get request by just putting the URL. So it's fine. Okay, so let's see what data do we need to send for this API to work. So we need to send create the user to-do. So we need to send for the URL, we need to send this data, label and is done. So now I'm going to make, okay, I will leave that there, and I will make another function. And I will say method post URL headers and body. Now the body, I have to send a string, right? And I have to specify in the headers that I'm sending application JSON. So the first thing I will do in the headers is say content type application JSON. Notice that content type, I wrote it in double quotes. right? What do you think is that? This is when we started learning JavaScript. What do you think I put the key with double quotes? It's not a valid variable. Right? It has a dash in the middle, right? If I do this, then that will be an error in JavaScript. Because content type is not a valid variable name, right? So that's why I have to put it in double quotes. So content type application JSON. That means that whatever I send here, I have to send it as JSON, right? Now, when you have an object in JavaScript, let's say I have this to do. And this to do is, let me see what is the signature. My to do is label and it's done true or false, right? Walk the dog. It's done false. When if I want to encode that in the body, I would have to use this function, JSON.stringify. So this is a function that will take the JSON and I will convert it to string. Okay. So now that I have this function, by the way, in this function I don't need a response, so I will not even, I don't even care to process it because I only need to send the data, right? So I will call fn2 just one time. And you see is wait, which one? Where's my post request? Not this one. Not this one. Huh. Oh, it didn't save. So something fell here. Oh, 204. 204 was 204 was created. But I don't see the
No content.
yeah, no content. But I don't see my to do here. Oh, body. It's not body. It's wait, is it body or fetch? Yes. Yeah, body, stringify. Content type. Oh, the T and type might be the issue. Nope. Huh. What's going on here? So we're calling
Content type.
wait, it's the same API? It's the same URL? Oh wait, it's a different URL. It's to-dos. You see, I'm sending the wrong request and the API is not sending me the right response. That's why I was confused. Here is to-dos. To-dos. I was sending it to to-dos user. So yeah, wrong URL. So we run this, 204, and if we run this, we should get the data. There you go. Right? It's kind of weird. Oh, yeah, it's an object with this data. Okay. Yeah, that's okay. Cool. Wait. Am I... Something wrong here. You see the error? You see the issue? I'm sending walk the dog and I'm getting back label string. This is incorrect.
Which one? On the async function?
Oh, actually, it didn't work here. That's the one that I sent from the... Yeah, that's the one I sent from here. Walk the dog. Okay, that's good. So that means that if I do this, I should get Ernesto, to-dos, label string stone, false, label walk the dog. Okay. So why it's not working from here? Oh, maybe.
Maybe you need the except.
No, it shows that maybe this is preventing me to make this request. So I have the right URL, I have the right headers, I have the right body, yeah. Yeah, it's probably preventing the request from.
Not the except categorized.
No, it's probably this environment is probably not allowing me to make that post request. Okay, well, you get the idea. This is the way we make the post request, right? We need to set the post, the URL, headers, and body. And for body, we use JSON stringify of the data that you want to send, right? And in headers, you have to put content type application JSON. Okay? So this is a way to make a post request. Now, you can do post request, patch, you can do delete request. You should have to change the method here, right? Change the URL if you need, change the header if you need, and send the right body if you need, right? Depending on what the API is telling you to do. Now, if you check that to-dos API, and please do, you will see that this to-do API has 7 operations, right? We have create user, delete user, read user, and read all users. Oh, this is nice. Let's try it. So we have all these users in the API right now. And here am I. Kevin. So who's Kevin? You Kevin? Cool. So we have read users, we have read users, so this is the one that you're going to use in your application. You don't need to delete it, create it maybe. And then when the to-do operations, you need to post to create a new to-do, put to update, right, the one that we're going to use to delete, and well, this is the one we're going to use to update that is already done. But if you want to, and you prefer to use the delete, it's the same thing, right? You can use the delete. Okay, perfect. Now, every URL has its own parameters. For example, in this URL, for reading the user, you see that the URL says /user/username. Use your own GitHub account as your username. So I will ask you to open or download this application, Postman. The name of application is this, Postman, right? So the okay. So in Postman is basically a client, an HTTP client that you can create the query, send it, and see the result, right? It's like a workbench. You can make queries manually and see how the API is responding, right? So what I want to do is to make a request, for example, for the URL in that. So this is the URL, users, Nesto, Freddy G. See? And that's a response. So I'm making a GET request to that URL. And that's the response that I get. Now, if I want to make a new query, I will make a POST request to the similar URL. In this case, it's to-dos, right? It's a POST request to that other URL. Now, in the headers, I would say, well, the body, I want to say raw JSON. And immediately you will see that it's going to be a header is the content type. Where is the content type here? If I say JSON. Oh. Label. Walk. Oh, by groceries. What was the other parameter? Is done. Is false. Right? So it's a POST request. This is the URL. This is the body. And you will see immediately when you select raw and JSON, you will see that in headers, there will be a content type saying application JSON because we selected JSON, right? So the header will be automatically added. And we can send the request, and that's it. We get the response. If I make the same query to get again, I should see that buy groceries here. So there is a backend, there is a server somewhere in the world that I can send this request, right? I can send GET request. By the way, another thing about GET requests, they don't change the data. So you can call it 1,000,000 times if you want, nothing happens, right? It will not modify the backend data. Now, if you make a GET request, a POST request, sorry, every time that you call it, it will send the data, right? And it will create a new to-do. So in this case, I will paint events. Created a new request, a new to-do, sorry. And there you go. Okay? So let's get some time to get familiar with the API and how to make the request. And then let's see how to combine this with the to-do application that we already have. Okay? So for now, just open Postman and make the necessary requests so you can have a list, have a to-do list. By the way, here it is. Create user, delete user, read user. So if you try to read your user and it says 404, you don't have a user, then you have to create a user. Use your own GitHub name, your GitHub account for that. Now, once you have a user, then you can create a to-do. You can update a to-do, and you can delete a to-do. So try to execute all these methods in Postman so you can play with that API so you know what to send and what are you receiving. Okay? Once we get there, then we can go to React, to our to-do list application, and then use these APIs using fetch. So when you open your application, it will fetch all the to-dos, and it will list in there. And every time you create a to-do, it will update it. Every time you delete a to-do, it will also delete it on the backend. Make sense? So Postman and this to-do API. Try to run all the methods. Create the user. Well, you need to create the user because, of course, your user will not be created. You need to be able to delete it, to read it. I mean, if you want to see all the users that exist right now, fine. Yeah, sure.
Far behind. So I'm trying to figure out what link you're talking about for
What
last
link?
class. You said you uploaded it, but I
Oh no,
don't see it.
I haven't yet.
Oh, okay, but
Uh-huh.
I do want to know, does it come on your personal?
Yeah.
one?
I will put it there.
Okay.
I will share it on Slack as well.
Okay.
See.